So the title is Microservices Adoption, Practical Lessons with Examples. Just a quick tip, if you want to draw more attention to your presentation, you just have to name it practical, pragmatic, advanced, or something like this, and you'll get the full house. Okay, little bit about myself. I'm a software engineer. More or less 20 years I'm doing this for a living. Also have delivered some projects during those years, failed a couple, and I'm still learning how to solve problems, how to work better, how to avoid some problems at all. Currently I'm working for a Norwegian company, but not all what I'm doing. Also I was participating in some community movements. One of the founders of Agile Latvia community, also was helping guys in Java user group community. So what? Yeah, computer is kind of slow with PowerPoint. What is this presentation about? I'm going to play a little bit Captain Obvious, so I'm going to say which things which you already know. Then I'm going to share my personal experience with microservices, with how to get screwed using microservices. And probably after that, I'm going to give you some food for thought. I'm going to ask a couple of questions. I'm going to give you a couple of things to take to consider before you dive into microservices. Yeah, so that's what I'm going to do. If you are expecting that I will show some code or name some frameworks, it won't happen. Sorry, I was thinking about it, but not this time, probably. So if you want to change the room, it's time to do it. Yeah. If not, it's not my fault. Okay. Actually, also about a little bit about microservices. Can you name me the most painful problem of software development industry? Anyone? No, 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 no. How about the word legacy? Who got the problem with this stuff? Raise your hand. Not that many. Okay, lucky the other half. Okay, so and the problem with the legacy is that we were writing many systems like 10 years ago or 15 years ago, and right now we are writing more discotheque. Right now we are writing even more software, and every year written software is getting older. It's getting older, and it's harder and harder to change something in it. It's harder to add some new functionality, and we are pushed to start writing the same systems from scratch or develop new systems and so on. So, and here the concept of microservices should help us. Like, if you cannot add the feature to your existing legacy app, you should create one microservice and integrate it with your huge monolith application, and they will live happily ever after. And yes, and maybe there is a thing that why should you create this big, huge monolith application if you could start with microservices, then changing this microservice system will be much more easier. You just will need to add more microservices or rewrite some of them which are outdated or functioning poorly or got crappy design and so on. Why wouldn't you do that? I was thinking about this and I thought, yeah, okay, maybe I should give it a try. So microservices, yes, the statement about microservices says that they can help you grow in a balanced way. Like you don't have to have this huge application, think about all the aspects of the architecture within one single app. You can create one microservice using Scala, another one using Groovy, another one using Ruby. Even PHP is not so bad in this case. And you naturally separate responsibilities within one monolith app. It may be not so clear that some developers tend to create classes which has 5 responsibilities which are responsible for many things. But in case of microservices, if you got one microservice responsible for retrieval some, I don't know, checkouts from database, second one responsible for integration with third-party service and so on, it's quite obvious that you will not have any possibility to insert the code which is part of responsibility of another component into this one. So yeah, the concept is that your software, pieces of software should be relatively small. They are presented to the outer world as an isolated system, and this system is highly adaptable. If you need something, you just throw into the system one microservice, additional one, and you got it. Yeah, the benefits of this approach, it's quite easy to scale the development. Like we got 3 people, we can develop 3 microservices, and then by the end of the month we can see how it works together, probably. Easy to deploy changes. One small microservice, it takes like 1 minute to build it and deploy it and start it, maybe even 10 seconds. Sorry. Also, when something is failing, it fails in one single piece of your microservice, and you can see it immediately. Also, as I mentioned, the technology diversity. If you cannot find some guys who are familiar with Scala, you can hire a couple of PHP students, and they will create the microservice for you while you keep looking for Scala zealots, and then when you found one, you can hire him and he will rewrite this PHP microservice. Sounds great, right? I think that would be all. Yeah, about microservices. But there are some, experiences which I got, and I bet a couple of other people in this room got. I know for sure about the one. Yeah, and I think so. Let's talk about my experiences. Couple of years back, I've miserably failed the project. The project died in pain and agony 9 months after I left it, due to some, not only it wasn't only my fault. Okay, there are a couple of people who did their best also, but we will talk about only what I was responsible for and what kind of practical stuff you can get from my failure. because you know the proverb that smart guys learning from other people's failures, stupid one like myself are learning, failing by themselves. Yeah, so, and I used to talk a lot about this project, about how and why it has failed, bothered all my friends, told them this story kind of 10 times. Each time we met, I was telling, I got a project this with microservices, and they were telling, yes, Dmitry, yeah, we heard about it. We know what was happening there. Perhaps you should stop talking to us about this. Perhaps you should go and see the specialist. And it struck me, yeah, I should go and see the specialist. So I applied to this conference, prepared this talk, and right now I'm seeing the full room of specialists. Yeah. What is the problem with conferences and stories people are telling on the conferences in general? In general, you cannot verify is this story true or not, and you cannot verify the success of what the person is describing, because maybe 3 months after this conference the startup will be closed, the technology will fail, and so on. So it's really like you are buying something in a black box, Schrödinger cat. So my idea is that you have to try yourself. You have to think for what kind of problem you are trying to solve, applying the successful recipe from the conference. And if you trying to solve the problem which is not non-existent, then probably you're doing something wrong. So my personal experience was that for this project, we have developed a small prototype monolith application, which was working more or less okay. But then I came to the conference, heard the topic about microservices, and I thought, wow, we should use this. There is a book written, I guess, even before my birthday, by Frederick Brooks called The Mystical Man Months, and he's describing the phenomena about the software architecture. It's called the symptom of the second system. When the person creates his or her first system, he tends to be very carefully choosing what should be done and how to do it, and usually he does what he have learned through working with other people. But when it comes to the second system, he thought that, okay, I know there are a lot of cool stuff, let's try it all. And that's why the second system tends to be more likely a failure than a first one. Yeah. So, about the personal experience, I'm going to tell about the 5 problems we met and failed somehow to resolve during this project. And the first one is how to expose our system to the outer world. Kind of sounds stupid. Yeah, we got the UI, which was nice, and a lot of buttons, a lot of JavaScript frameworks. It was working, but when it came to exposing the API for this system, we found out that we haven't thought about it at all. So our API was shitty, was kind of drafty, and there wasn't any way to make it more nice looking other than rewriting it from scratch, which was made by another person. So second, problem is, do we really need the technology diversity? Do we really need to have in one box lion, mouse, and a giraffe, for instance? Do we need to try to mix PHP, Ruby, and something else within the system? Even if you, sorry, if you are using Java frameworks, what if the one component will be written using, for instance, Spring, and second component will be using Juice from Google? Do you really want to end up that one single person who mastered this and exactly this technology will be owner of this component, and the other will be afraid of touching it? So third problem is how to find what really is broken. For instance, you got 3 or 5 microservices, you exposing the common API for those services somewhere to the world, and something in this API seems not right. Some data are missing, or some corrupted, or something like this. But looking on the JSON response or XML response or whatever, how can you find what really was broken? It's good if your design of API and of your services shows you immediately which data is missing. But what if there are many services which interact between themselves while calculating the data you need, and then it returns to you? So you have to figure out which exactly service. And it's quite good if it throws an exception. You can see it. But if it just doing something wrong, but still not throwing any exceptions or error messages and so on. So how could you find it? Problem 4. Your colleague, for instance, have created a shiny new version of his microservice, deployed it to beta environment, and forgot to mention you. Then your another colleague, test engineer, came to his place at the morning, started to test it, and found something strange. And he came to you, asked about it, and you spend 3 hours trying to figure out all the data flows through the services. And then it appeared that one service works differently because it's a newer version. How can you solve this? Another problem which is connected with external API. Can you really see where your data is coming from? What exactly database is used, or external service to pull this data, and so on. So how do you see in the resulting set of data which data source has affected your final result set? So there are problems to address, and after thinking about those problems, after reading a lot of blogs since last couple of years, there are a lot of stuff has been written about microservices in particular, and also there are a lot of good books about service-oriented architecture. I came up to some conclusion. Probably it's not a rocket science, it's not a breakthrough in the software development industry, it's just my experience which I'm sharing right now with you. And okay, those are things you need to decide while you're on shore, while you haven't initiated your microservices project, product, whatever. 5 things you need to build before, or at least keep in mind that you need them. before you started to create and stamp your microservices. So it's API, external API design principles. It's your failure strategy. Tools, because there are many talks and articles about that. Actually, microservices are about the DevOps stuff. If you haven't DevOps, you'll be in pain. If you haven't prepared your DevOps infrastructure, your deployment stuff, you'll die in pain too. Fourth thing is service discovery. And last but not least, it's health check services or systems or whatever you call. So again, conclusion from my experience that external APIs should not be UI driven, because when you talking to your UI developer, he tells you usually, I need this, and this, and probably would be better if I could get it within one response. And you starting to think, okay, probably we can make it. Yeah. It will be ugly, but nobody will see it. But when you're going to publish your API, everybody will see it. And probably nobody will want to use it. Or if we are talking about, I got a lot of experience integrating some Norwegian state-owned services with other state-owned services, and ugly design is still quite common in our world. So let's just not multiply it. Also, you have to think how you are going to expose different versions of your API. For instance, if you are doing some major upgrade, you need somehow not to fail all already working integrations with your service. You need to keep serving them, but on another side, you need to publish your new API and let other people start doing their integrations. And this switch should be done kind of painlessly, because otherwise you will need to synchronize all the upgrades with all your customers and so on. And also you need to think how you are going to reflect within your API the internal failures of the system. So then we comes to failure strategy. First, as I'm thinking about it, there are 3 gradations of failure. Total failure, for instance, user cannot authenticate himself, and you're not allowed to show anything to authenticated user, or your authentication service doesn't work at all. It's a total failure. Yeah, partial, when something doesn't work as it should, but the rest of your microservice is providing the data, doing the calculations, doing some data alterings, and so on. So probably you could serve this request, and then it's up to third-party system to figure out what to do with your data. And then everything works fine, yeah, but some data are delayed. Instead of waiting for 5 or 10 seconds while probably one of your services will serve the data, maybe it would be better to say, okay, this data takes too much time to retrieve. It's our fault. Take the rest of the data and do anything you want. Also, who is familiar with the circuit breaker pattern? Quite a lot. Good. So yeah, I think it's since we are talking about the distributed system, it's must-have in your stuff too. Who does not know what circuit breaker is? Please do not raise the hand, but just Google it. In Wikipedia, there is a really good article about it, and it's not a rocket science again, so read it afterwards. things about deployment, dependency management, and so on. So now it's my speculations, because that's what I would like to have if I will try to develop microservices application once again. I would like to be able to deploy one specific version of the entire system into specific environments. No, whatever. Not picking them one by one and trying to figure out which version of this microservice could be conflicting with the other and so on. So I would like to specify, I want to deploy system version 0.5 to this environment and all your microservices will be in place. Probably there are such tools. Unfortunately, I haven't done too much research on this. Sorry, family is calling. Okay, another thing I think we need to have, it's just to, before your system will start, it should check that all the dependency, all the probably each service should check if the all services he needed needs are in place, and if there are something missing, some of them are missing, he should raise the red flag then. Okay, we cannot work. Deploy the missing components, also kind of possibility that service should be checking if something is missing and be able to say to your deployment systems that you need to add those ones. But that, I guess that's my wishful thinking more than reality. I don't know. When service is deployed somewhere, it should be registered somewhere in order to allow to other services find it. Also, what you need to take care of, trying to work with microservices, you need to have environment provisioning. That's a really cornerstone of your DevOps practices and so on. But I think it's worth to mention it once again. Service discovery. For instance, if you got 5 microservices, each of them at least has 2 instances, you need to handle 10 configuration files, right? If you're going to have more instances or more services, configuration files became more and more. Of course, you can do some provisioning stuff, and still you have some in your configuration. You have some nodes which you need to change for environment. You need to specify IP addresses, host names, and so on. Instead of this, there is a pattern called service discovery, which suggests you that once your service is up and running, it should be registered somehow, either by deployment tool or by itself. It should be registered somewhere in a service registry, so other services, when they are about to call it, they could discover instances and then choose the proper one. So, and when the services got stopped, they are deregistered, unregistered from this service listing. So there are two approaches for this service discovery. Client-side discovery, when the client pulls all the data for service it looks for, and then chooses which one it's going to call, using either some load balancing or randomly picking. Second strategy is server side. So when you call the server and telling, give me the billing microservice, and it gives you only one instance which is stable, which is safe to call, and so on. So health check systems. Probably when you got something wrong in your application, you want to check the log files. If you got multiple instances of one microservice, you need to check multiple log files, and so on and so on and so on. If your error is triggering by a couple of components, you want to see what's happening inside each of components. So you need really to have a log aggregation stuff. We in our company Ambita, we are using log faces for this. Others are using Logstash and so on. So it would be great also, if we're still talking about health check, it would be great to see kind of dashboard where all your components are listed and you can see which version, how many instances, what about the statistics, how many requests it serves, how much time it takes, and so on. There are also a lot of monitoring tools which monitors microservices and applications from system administrator points of view. They monitors memory consumption, CPU consumption, and so on. It also could be integrated, but what I'm talking here, it's just kind of to have a kind of visual representation of what's going on in your system, what you have in it. So ideally, I'm not very good at drawing, so could be something like this. Ideally, when you're going to create your first microservice, you should have decided about all of those things, and you should have them in place. Then you can start creating your microservices. Also, I highly recommend to check blog by Chris Richardson, the microservices.io, where he discussing more about those microservices patterns and so on. I'm not sure if you are able to read those titles. Are you, guys? Can you see the characters here? Because I'm from here and I'm not able to read it. But yeah, this is how landscape of microservices should look like. So now we are moving to highly opinionated part, where I'm going to tell you that you don't need microservices at all and you can live happily ever after without them. Or maybe you will not. Once again, it's a problem of conferences species. What's good for me maybe not would be not good for you, and you have to decide and find out it by yourself. So what I'm thinking about, it's when not to use. When not to use microservices. Yeah. First, if you have single point of failure in your system, probably you shouldn't be using microservices because there is no point for it. When the load is equally distributed among your services, if, for instance, each call from external world takes to call 60 or 80% of your microservices at once, probably it's better to have them in one application. If you don't need real high availability stuff there, if it's just okay to do the maintenance outside of office hours or on a weekend, if you can, if nobody would be hurt, kind of damaged, or no business will fail, if some of your services will be down for 10 minutes, maybe 1 hour. If you don't need dynamic scaling, like in a cloud when the load is high, you can turn on some instances of your services and pick up the load on themselves and everything will be fine. If it's okay for you, if you know that there won't be more than 200 customers during the entire life of your application, it's okay not to have microservices, just to have two node cluster with a monolith application, and it will be working fine. If something would be taking too long to work with, then okay, users may suffer. Once again, if you do not have a relevant infrastructure, if your infrastructure is still in construction, if you have the good practices how to do deployments, provisioning, and so on, then please do not use microservices. Okay, when to use? When you're pulling data from multiple different data sources, then probably your data sources may work with different speed. Response time could be different. Also, yeah, of course, if you're pulling data from a local database, it's kind of milliseconds, 3, 5, if you need it. If you're pulling data from a remote database, it's 10 times more. And if you're pulling data from a web service, it's even more, and so on and so on. So probably you would like to serve those data differently. Remember about this failing strategy and so on. So you may need several microservices working with different data sources. If the size of your services is quite different, for instance, one service doing some batch jobs by the night, and you want to write it once and deploy it and never touch it again, and other service experience a lot of external requests and so on, a lot of changes and so on. So you might want to isolate the rest of your system from this one and keep developing it, maybe splitting it into several microservices additionally. But microservices give you such an opportunity. Yeah. For instance, when the high availability is required, of course, microservices is a good way to solve it, because the probability that you will have all your services down is much lower than if your system consists of a cluster with 2 nodes and all the clusters will be broken at one time. When your components serving data or doing some logic from different domains, it's also quite dangerous to mix things together, because even in different domain, things may have a same or similar name, and putting them into one application, it's going to confuse developers quite a lot. I'm not talking about if some newbie will came and change some classes which are related to different business domain, and the rest of the team will spend a lot of time trying to figure out what was done. If there are many teams are working together, especially geographically distributed, so you may end up defining contracts for your internal microservices, and then each team will go to their cave and spend kind of months or 2 developing this microservice without changing contract. And of course, if you have your infrastructure in place, by infrastructure I mean health check services, deployment, continuous integration, continuous delivery probably, environments provisioning, and so on. So, just to recap, when we don't need it, when the load is equally distributed, when high availability is not required, when dynamic scaling is not required, when there is no infrastructure to support microservices concepts. When we need it, data sources are coming from different sources, high availability is required. Several teams are working together, or team is geographically distributed. So it's a good way to split the job. And the infrastructure is in place. Where to go next to think about microservices? It's of course microservices.io. On InfoQ there are a lot of talks, really inspiring talks about microservices. Actually, Nginx also, they are, right now microservices is one of the selling points of Nginx. So they are providing a lot of webinars, free books, and other kind of materials, articles about microservices, and of course how to build microservices using Nginx. Also, the last one is my blog. There is only one article, but I hope I will add a couple of articles more when my company will be migrating to microservices and cloud and so on. Yeah, also in conference program schedule there was a tag cloud assigned to my speech, and really I was thinking to talk about cloud, but it was when I was applying to this conference half a year ago, and when I started to prepare my slides, I did not remember what I wanted to talk about related to cloud. So here is the cloud, and we are done. So, questions?
If you have several microservices that depends on one another, then is there some way to like prevent such a situation that you like remove some API or deprecate it, and instead of returning needed result, it returns some crap because I don't know, database changed or algorithm is changed. Like how to prevent such a situation that some API is deprecated or removed at all.
Okay. Probably you may have different versions of the same microservices. So when you're changing some microservice, you might want to be sure that nothing is failing, which addresses the old version. So you may keep two versions of one microservice. It's an additional overhead, of course, but it's one way. Or you have to synchronize all the changes.
I, so in your opinion, how big should be a microservice?
Big for what?
I mean, like, how many lines of code? How many methods? How many methods?
Once again, what is the purpose of your question? What is the purpose of microservice also? What kind of microservice we are talking about? The spheric microservice in a space, or?
Didn't get your question.
Okay. Oh, what I'm trying to propose here is that you have to be specific with your questions to get the specific answers. Microservices could be differently. It could be 100 lines of code or 1,000. Things that you need to scale your system by design. You need to design it scalable in this way. That one microservice should have single responsibility, either serving orders in a restaurant or calculating the menu price and so on, providing delivery options, something like this. Further, if you need, you may split it in several sections, but it's really quite empirical, and I'm highly doubted that if I tell you 100 line, it would help you in the future.
Thank you.
I got rather a general question. What is the difference between microservices and service-oriented architecture from your point of view?
Actually, microservices evangelists, they're saying that microservices, it's SOA done right. So I don't think that it's kind of there is a big difference, rather than it's just marketing and so on. Because you can create an ugly system using SOA or microservices or monolith application either.
So what's the alternative? So if we don't use microservices, we still need isolation, right?
Yeah.
We need to make sure that the, like you mentioned, the menu system and bill calculating systems are different. And when we change one, it doesn't infect the other, right?
Yeah.
So there's always GEI and other stuff also.
Yeah, of course.
But what do you recommend, or what do you, have you looked into that?
Yeah, yeah. We've been using some, during the build, we've been using some tools which were checking that in Java, that one package does not refer another package, which kind of gives us level of separation. Also, we can create a multi-module project, which also gives us some isolation. So, if no questions, oh, no, sorry, over there.
What about common package, where you put code which will be needed in all your microservices? Should it be copied or simply created as one common package for all?
Probably you could have some common module, because in many microservices you are using third-party libraries, all the same for every service. So why can't you have your own common library for this stuff?
What messaging format you using between microservices?
Sorry?
What messaging formats are you using between communication of microservices?
In this particular project, it was REST services.
Do you have any benefits or some issues with that?
No, issues of this project were in wrong design choices and different stuff which does not relate to this presentation. So it's not REST why it failed. Okay, I think we are done here. So thank you everyone for coming.